Okay. So let's go through the two homework problems from yesterday, and then we'll get started with the lecture for today. Just a quick show of hands. Who did these two problems? A few of you. Okay, cool. So let's have a look at the first one. So we see we have the x cubed, and I gave you the hint. If it's x cubed, you have to do that integration by parts 3 times. Okay. Like that previous one we had with the x squared, we had to do it twice. Okay. So if we have to do it more than 2 times, you should use that table method with that dr thing. So let's go through that for this one. So x cubed, that's the polynomial part. So we let that be u. And then everything else there, the e to the 2x dx, that would be our dv. Okay, so we're going to have u equals x cubed. So that's the one that we're going to differentiate. That's in the d column. And then dv, that's going to be e to the 2x dx. That will be under the r column. That's what we're going to be integrating. Okay, so let's set up our table. So we have d and I. Okay. So the first entry is just what we pick for the u and the dv. So that will be x cubed and e to the 2x. Now down the first column, we differentiate until we get that 0, and then we can stop there. So x cubed, the next one's going to be 3x squared. Yep. The next one. 6. Yep. 6. And then the next one will be 0, so we can stop there. Okay, now we go down the r column. That's where we integrate. So the integral of e to the 2x, that's going to be? Yeah. Next one? Yeah. Okay, and then the next one? Yeah. Yeah, and then if you carry on, it'll be 1/16th and so on. Okay, now you can go down with it. Okay, so we've done with that. Now we got the plus minus thing to add. So it will be plus minus all the way down. And then we need to match up the diagonals. So the first one in the first column with the second in that second column there. So let's fill that in. So this one with this one, that one with that one, that one with that one, and that one with that one. Okay, so you just match up the diagonals. Once we've done that, we can write out the solution. So we have the x cubed with half e to the 2x. Okay, and then the next one comes with the minus. So that will be minus, then we have 3/4. Okay. Then the next one will be 6/8 with the plus. Okay. And then the last one, that will be with a minus 6/16. Okay, and once we're done with all of that, we put the plus c. Okay, so those that did the homework, did you get this? Okay, good. Now the next one, a little bit more difficult, but not too bad. So the integral of e to the x cos x dx. For this one, I'm not going to use the table method. I'll use that other one, just so that we have practice with the two methods. So this was homework number 1, and then homework number 2. Okay. Sorry. So we have e to the x cos x dx. So let's fill that in. Okay. So I said last time, it doesn't matter what you pick. So if you pick u to be e to the x or u to be cos x, you get the same answer in the end. So let's just pick u to be e to the x and dv to be everything else. You can swap it, you get exactly the same thing. And we just follow as normal. So we need du. What's that going to be? Yeah, it stays the same. And then on this side, we need v, so we integrate. Integral of cos, sine, very good. Okay. And then we can use that formula, right? So I'm sure everyone knows it by now. So it's the integral, how does it go? U dv equals, yeah, 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 good. Okay, so I think everyone knows it by now. So let's fill in everything. So u dv, that's what we started with. Okay, uv, that's going to be this diagonal here. So e to the x sine x. Minus, and then we have v du. That's the bottom part here. So this is similar to what we had before with the x squared cos x. Over here, we need to do integration by parts again. Okay, so we have to do it a second time. So let's put that in the green box here. So let's do that again. Again, the order doesn't matter. You can pick u dv however you like. So let's just stick with what we had before. So u equals e to the x. dv is sine x dx. Again, you can swap it, so you'll get the same thing. Okay, so we need du and v like before. So du, that stays the same. Integrate. Integral of sine. Negative cos, good. Okay, and then we use the formula again, so we just substitute. So integral u dv equals u v minus integral v du. Okay, so let's substitute. So the first one, that will just be e to the x sine x. Remember that was from the green box that we had. So this is equal to u times v, so that's this diagonal here. With the minus from the cos there. Minus integral v du. So that there. Okay, and again, got that minus on there. Yeah, just be careful of these minus signs here for the second term. Okay, there's always that minus in front that you have to worry about. Okay, so we got that other minus sign, and then e to the x cos x dx. Before we substitute back, I just want to turn those two minus signs into a plus. So we have minus e to the x cos x, and then minus and a minus, we can make that a plus. Integral e to the x cos x dx. Okay, now something interesting here. The second integral over here that we get from doing by parts twice is exactly what we started with over here. Okay, so we're going to substitute for the green box, and we'll see there's some now simplification we can do. So again, all of this was the green part. So let's substitute that in. So we had the integral e to the x cos x dx. This is equal to what we had before, e to the x sine x. Minus, and then everything in the green box, that will be this green part that's underlined here. Now let's distribute the minus sign. Yeah. Where?
On the substitute.
Oh, yeah, yeah. Thank you. Yeah, there's a minus. So minus there with minus there. Thank you. So that will be e to the x sine x. Minus and a minus, so that will be a plus now. And then minus here with this. Oops, cos x dx. Okay. Now notice we've got this term over here in blue. And then on this right-hand side, we have the same term with the minus sign. Okay, that's important. So we have the same term over there. If we take this over to that side, it's going to double up. Okay, and then these other two, we're going to just leave there. Yeah. Finally, that integral, that's what we want to solve for. So let's just take the 2 over, so half on both sides. And then once we're done, we can put the plus c. Okay, those that did the homework, did you get this? No? Anyone got it? Okay, that's fine. So please take this down, and then for homework, try the other one. So integral e to the x sine x. Okay, so try this one for homework. So you know the idea on how to do it for the previous homework. Try it with this one, but now instead of cos, it's sine. Okay. Any questions for the homework from yesterday? So you okay with these two? Okay. Let's start the next part, the integration of inverse functions. Okay. So we're going to be looking at how do we integrate certain inverse functions. For example, the natural logarithm, right? That's an inverse function. Those inverse trig functions, sine inverse, cos inverse, tan inverse, for example, inverse hyperbolic trig functions. Remember those ones? Sine hyperbolic inverse, cos hyperbolic inverse, and tan hyperbolic inverse. Okay. So we want to look at integrating these functions. Okay, so let's start off with the first one. So we have the integral of the natural log of x dx. Okay, now to do this, we're going to use integration by parts. However, it looks like there's only one function there. So how do we choose our u and our dv? So what we're going to do is imagine this as the integral of the natural log of x times 1 dx. Okay, so we put a 1 function there, and now we're going to choose our u and dv by choosing the natural log here to be u, and everything else, this 1 part, that's going to be dv. So whenever we have an inverse function we want to integrate, we let u be the inverse function, and everything else, whatever it is, that will be dv. In this case, it's 1, but not always, right? It could be the integral of x log x. But then you do the same thing. So you let u be the inverse function, everything else, that will be dv. Okay, but we'll look at an easy one for now. So we're going to have u Okay, so the inverse function here, that's the log, so that will be u. And dv, that will be everything else. So that will be the imaginary 1 we're just putting there. Okay, and we follow everything exactly the same. So du and v, so here du, what's that going to be? 1 over x. Then integrate. So v will be integral of 1 x. Yeah. Okay. And then we just set it up exactly the same with that formula. So we have integral u dv equals u v minus integral v du. So we have the integral u, that's going to be the natural log of x, dx is equal to uv, so we look at the diagonal, okay, minus the integral v du, so we look at that bottom part, so that will be x over x, so that will just be a 1, right? X and 1 over x, so that's just a 1 there. Okay, so this will be x log x minus x plus c. Okay, so please put a box around this. This is an important integral you'll need to know. So please add that to the list from that previous table we set up. Right, we had the power rule, we had all of the trig integrals, and so on, the hyperbolic trig integrals. Please add this to that list. Okay, let's make this a little bit more complicated. So number 2, we have the integral of x log x dx. Okay. Now remember from the previous lecture, the rule number 1 and 2, if we had a polynomial part, we let that be u, right? And if we have anything else, we let that be dv. Now we're going to have rule number 3. If there's an inverse function, you always let that be u. Okay, that goes above rule 1 and 2. Okay, so whenever there's an inverse function, like the logarithm or any ones from the list above, that's always u. Okay, so please add that as rule number 3, and that goes above 1 and 2. Okay, so here we're going to have u equals natural log of x, and dv is now the polynomial part. Yeah. And we follow everything exactly the same. So we need du. So what's that going to be? 1 over x. And integrate this. What's that going to be? Half x squared. Okay, and then we can set up the formula. So integral u dv equals uv minus integral v du. Okay, so let's substitute. So integral u dv, that's what we started with. So that is the integral of x log x. Okay, uv, that's the diagonal parts. Minus the integral v du, so we're looking at the bottom. So we have half x squared divided by x, so that will just be half x. Okay, and then a nice easy integral to do there. So this is going to be 1/2 x squared, natural log of x, minus, then we get another half, so a quarter x squared plus c. Okay, is everyone okay with this? All good. Okay, let's have a look at number 3. So we have the integral of sine inverse x dx. Okay, So immediately we see we have something with an inverse function. So that is immediately u, and everything else, that will be our dv. So u equals sine inverse x, and dv, that's everything else, but that's just the dx left over. Okay, so du equals, what's the derivative of sine inverse? Check your notes. It's in that table when we had the derivative of inverse functions. Square root 1 minus x squared. Very good. Okay, remember last year when I said this is important, make that table. This is why. Yeah, because when we're looking at these problems, you need to flip back and actually look for those derivatives. Okay, so if you lost your book from last year or you threw it away, please make sure you redraw that table. Okay, all of those derivatives for the trig functions and the inverse trig functions, inverse hyperbolic trig functions, please make sure you redo that. Okay, so here v is just x. Okay, so formula again. So integral u dv equals uv minus integral v du. So integral sine inverse. Okay, that will be uv. So we look at the diagonal. Minus integral v du. So that's the bottom part. Yeah. Now we've got this thing to do. How do we solve that? U substitution. Yeah. So remember yesterday, I said these techniques are going to get mixed. Sometimes you have to do integration by parts twice. Sometimes you have to do integration by parts and then U substitution. So there's quite a lot going on. So let's have a look at the green one now. So we have the integral x over root 1 minus x squared dx. And now we're going to do a U substitution. Now, we've already used u over here, so let's use another variable so we don't get mixed up. Let's call it t. You can call it whatever, I just don't want to mix it up with that other u. So we have something like this, and we've got a clear outside function, inside function going on. So what should we let t be? Yeah, 1 minus x squared. That'll work. Okay, so dt, that's going to be minus 2x dx. Okay, here we have minus 2. Over here, we don't have anything in front of the x, so we take it over to the other side. So we have minus 1/2 dt is x dx. And that takes care of that top part there. So this is going to be equal to the integral of minus 1/2 dt. Okay. And then we've got 1 over root t from there. Yeah. Did everyone see how we did the substitution? No. Which part did we lose you? The substitution part. Okay, so here t is 1 minus x squared. There's 1 minus x squared, so I put a t. Here at the top we have x dx. Here we have x dx, which is minus 1/2 dt. So I put minus 1/2 dt. Okay. Anyone else? You're good. Okay. So let's simplify this. So the minus 1/2 we can put to the front. We can change the root to an exponent, so we can use the power rule. So add 1 to make it a half, divide by that, so times by 2. So we have minus root t. Yeah. Now we can't leave it as t, we need to put the x back there. So instead of t, we put 1 minus x squared back. Okay, and remember this was that green part still. Okay, so that's the green part of our previous working here. So it's going to be this minus the green part. So it will be minus what we have over there. Minus and a minus, that makes a plus. And we can put the plus C right at the end. So you see we start getting the mixing of integration techniques. Okay, towards the end of the semester, we're going to have problems that need 3 integration techniques. So you're going to start with integration by parts, then there's a U substitution, and in the U substitution, there's a trig substitution. So there's like 3 things going on. Okay, but that'll be later in the semester. Any questions before we move on? Oh, good. Okay, we got one more for today, and then we can go. It's getting way too hot now. Okay, so that was number 3. Number 4. So we'll do one more in class, and then the other I'll leave for homework. Okay, so we have the integral of arctan x dx. Okay, remember the different notations. So over here, we wrote sine inverse. I could also ask the question as arcsine or arctan. Okay, so please make sure you know the different notations there. Okay, so you don't want to mix up your problems there. Okay, so same thing. We've got an inverse function. We always let that be u. That's our new rule number 3. So u equals arctan x. And dv, well, that will just be dx. That's all that's left over. Now we need du. Derivative of arctan. Yep. You all got it? Okay, and then the v, that'll just be x. Okay, same as always, substitutes into that formula. So we have the integral u dv equals u v minus integral v du. Okay, there's always 1 mark for the formula, right? So you all got 1 out of 5 so far. Okay, we need uv. So that will be that over there. Minus the integral v du, that bottom part. So it will be x over 1 plus x squared. Okay. Now, what do we do with this? Use substitution, yeah. So let's put a box around that. So we're going to do that on the side, and then put it all together at the end. So side working, we've got the integral x over 1 plus x squared. Now here, it's like those other problems we looked at. There's no inside function, outside function. So we need to figure out what u should be. So what should we pick? We don't have much to work with. U equals what? U equals x squared. U equals 1 plus x squared. So both of them will work. Let's go with the second one. So u equals 1 plus x squared. Yeah, if you just say u equals x squared, you get exactly the same thing. So du, that will be 2x dx. At the top, we just have x. We don't have 2x, so we take the 2 over. That's all we need to do. So let's substitute. Oh, I called it u. Okay, just don't get mixed up with the other u, but I'm sure you get the idea. So this is 1/2 integral 1 over u du. So that's 1/2 natural log of u. Don't need the plus c, you can put that later. Please remember your absolute values, right? Okay. And then we substitute back. So the 1 plus x squared goes inside. That's 1/2 natural log 1 plus x squared. And again, this is that green part. Any questions for this part? Okay, quite easy, very similar to what we did last year. So let's put the green part back inside there. So we're going to have the integral arctan x will be this first part from our previous working. Yeah. Then minus the green part, and we said that was that half log. Okay. And then after all of that, we can put the plus c. Okay. Any questions for this one? Oh, good. Okay, so I'll give you one homework problem to try out. Please remember to have a look at those tutorial questions. Okay. So for homework, the integral of x cosine inverse of x. Okay. Remember, even if you have a polynomial part in front, okay, we don't use that 1 and 2 rule. As soon as you have an inverse function, that's u. Okay. Otherwise, it gets far too confusing. You can try the other way, but it's quite messy. Any questions for the homework? Okay. So for next week, we're going to start on the next integration technique. Please have a look in the textbook. So we're just flicking through. So in the textbook, we're done with the integration by parts. Please start reading that next chapter. Okay. Then the quiz and TUT test. So that will be on Monday, right? Monday. Okay. So like always, we'll meet in the DC LAN. The tutors will be there, so you can go into your groups with them. I will post the tutorial assignments, so you split up the questions in your group. Okay, answer those. It'll be like 2 per person, very quick to do. Show your tutor, they'll check you off the class list, and then you can prepare for the quiz. So the quiz will be 10 MCQ questions on U substitution and integration by parts, up to and including this part here. Okay, so 10 for that. And then for the written part, it will be 2 questions taken from the tutorial. Okay, just 2 written ones, so nothing too bad. Any questions for that? All good. Okay, I'll see you Monday.